If we're not working with a table, we have to work with a compound interest formula. In your lesson, they give you two possibilities to use for compound interest. Either one will work. I think they just thought that this one had better variable, had better letters to stand for things. These are really the exact same formulas. Okay, so A here is the amount you end up with in your account. P is the principal, that's the amount you invested. Okay, 1 plus R, this is your interest rate or your APR, and N is for the number of years. Okay, so again, they have the same formula down here, but it just stands for things that make more sense to us. Maybe FV is the final value, IV is the initial value, R is the rate, and T is the amount of time. Okay. Let's try one of these out. It says Del Mortzberg deposits $1,000 in an account that earns 2% interest compounded annually, so each year. What is the future value after 15 years? She makes no deposits or withdrawals, just leaves that money in the account. I'm used to using this formula with the P's and the A's, so that's what I'm going to use. So the amount is what we're looking for. P, the principal, is the amount we put in the account. She put in $1,000. Times 1 plus the rate is 2%. Again, do not forget that we have to move the decimal 2 places to the left before using it in a calculation. So we have 1 plus 0.02 for our rate. To the N, N is the number of years, okay, or number of times it's compounded, 15 times in 15 years. Now here you want to be careful. I have everything in my formula, but I need to be careful and make sure I use the correct order of operations. You have to do parentheses first. So first we add the 1 and the 0.02 to get 1.02. The next thing you're supposed to do is exponents. Now exponents are small numbers we write up here. Remember, this means we're taking 1.2 times itself 15 times. On your calculator, there's a couple of buttons. Some calculators have a button with a little caret that looks like this, and you would put that in there, because you don't want to have to do 1.202 times 1.02 times 1.02 times 15 times. You can, but that's not the best option. There may be other calculator buttons that look like this, with a little Y, with a little X above it, and it may even be reversed. So that's what some calculator buttons look like that you may use for this. Not one with a little 2 or a little 3 on it, okay? You want either X's and Y's or this little caret. Let's try that out. So take out a calculator, try it out. You will need a calculator that does exponents for this class, okay, whether it's the one on your computer or another. And when we do that, 1.02 to the 15th power, again, that's not times 15, it's times itself 15 times. I get roughly this number. Just leave that number in your calculator and go times the 1,000. So the amount in the account at the end of those 15 years will be $1,345.87. Okay, if you have questions about using your calculator for this exponent part, please contact me, because that will be very important. All right, here's Barbie Spencer. Barbie Spencer wants to have $100,000 in her savings account in 25 years. Okay, so this is the amount A. That's what she wants to end up with. If her account pays 6.6% interest and it's compounded annually, what does her initial investment, okay, so that's her principal or her P, need to be if she wants to do that? Okay, so we start with our original formula again. And we fill in the information we know. This time we know she wants the amount to be $100,000 when she's done. We don't know how much she's putting in, so we just put a P there. In here we have 1 plus the rate was 6.6%. So if we move the decimal over, we get 1.066. And the number of times, or it's 25. It's in there for 25 years. Okay? Let's do some solving here. So on this side, we really can't do anything with the 100,000 yet. But on the left-hand side, we follow our order of operations once again, and first add inside the parentheses. The next thing we're going to do is calculate 1.066 to the 25th power. So again, you would multiply it by itself 25 times, which again on your calculator could be a button that looks like that. It just depends on what kind of calculator you have. Or it could be a button that looks like this with a little X to the Y. When you calculate that, you should get 4.9423 approximately. So we have $100,000 equals P times 4.9423, and it goes on from there, but I'll just round it off. Now we want to solve for P, so finally the last thing we do is divide both sides by 4.9423 to find our missing value. Again, we're just using our algebra skills so that it'll all work out. And when we do, we end up with 20,233.49. So if she wants to have $100,000 in 25 years, she needs to invest $20,233.49 right now. If